All right, so in this section, we are going to be writing and solving one-step equations. The success criteria is I can apply properties of equality to produce equivalent equations, I can solve equations using addition, subtraction, multiplication, or division, and I can use equations to model and solve real-life problems. So we're going to go over the addition and subtraction property of equality. So you can see the words on the screen, but basically what these mean are if you add the same number on both sides of an equation or subtract the same number on both sides of an equation, you get an equivalent equation. So all this means is you can add or subtract the same number on both sides of the equation and that equation will still be true. So for this example, we see that we are solving equations using addition or subtraction. So to solve this equation, x minus 7 equals negative 6, we need to see what's happening to our x value and then see what we need to do to cancel that operation. So I'm going to zoom in here on the first one. And we see that x is being subtracted by 7. Another way to think of this is we have a negative 7 term with our x term. So to cancel out minus 7 or negative 7, we are going to add 7. But in order to keep these equations equivalent, if I add something on one side, I need to add that exact same value on the other side. And since I've done it on both sides now, our values won't change, and this equation will be the same. So if we see negative 7 and then plus 7, these cancel out. This would be 0, but I don't need to write that. This is just going to be x on the left side. And then all I have to do is negative 6 plus 7, which is going to be positive 1. And that's my final answer. In order to check this, I could plug 1 in or substitute 1 in for x in the equation. So if I had 1 minus 7, that is going to equal negative 6. So I know that my answer is correct. For part B, solve 1 equals w plus 6. So once again, we want to see what's happening to our variable. And in this case, our variable is being added to the number 6. So we have a plus 6 here, and we want to get rid of everything except for our variable. We want to isolate our variable, get it alone. So to cancel out plus 6, I want to subtract 6 or add a negative 6, which is the same thing. But remember, if I do something on one side, if I change the value on one side, I have to change the value by that exact same amount on the other side. So since I subtracted 6 here, I have to subtract 6 on the other side of the equation. So now, the positive 6 and the negative 6 cancel because 6 minus 6 is 0. And for addition and subtraction, adding or subtracting to 0 means it's canceled. So now I'm just left with w. And then over here, 1 minus 6 is negative 5. Once again, I can check my answer by plugging negative 5 in for w. And negative 5 plus 6 does equal 1, so I know that I have the correct answer. For the last example, we're going to solve y plus 3.4 equals 0.5. So here, I look at my variable, which is y, and I see what's happening to it. We're adding 3.4. So in order to cancel out this plus 3.4, I need to subtract 3.4 or add a negative 3.4. And whatever I do to one side, I have to do to the other side. So I'm going to subtract 3.4 on both sides. On the left side, 3.4 minus 3.4 is going to cancel. So I get y here. And then here I have 0.5 minus 3.4. Well, if you're not sure, we see what number is the absolute value of the number is bigger, which is going to be 3.4 is bigger. So I know my answer is going to be the sign of 3.4, which is negative. So I know I have a negative answer. And then since the signs are different, I just subtract these. So I'm going to do 3.4 minus 0.5. And then I can't do 4 minus 5, so I'll borrow. So I get 14 minus 5, which is 9, and then bring down the decimal, then bring down the 2. So my final answer is going to be y equals negative 2.9. And then once again, I could plug this in to check. Negative 2.9 plus 3.4 does equal positive 0.5, so I know my answer is correct. So the same exact properties work for multiplication and division. Whatever you multiply on one side of the equation, you have to do on the other side of the equation. And whatever you divide on one side of the equation, you have to do on the other side of the equation. So anytime you're changing a value by using an operation in an equation, on one side, you have to do that exact same operation on the other side in order to keep that equation true. So now we're going to be solving equations using multiplication or division. So in this case, we're going to solve negative 3 over 4n equals negative 2. So I'm going to zoom in on this. And we always want to see what is happening to my variable right now. Well, my variable is n, and it's being multiplied by the fraction negative 3 over 4. Now, normally, in order to cancel out multiplication, we would do division. And you could divide by negative 3 over 4, but there's actually an easier way. All division is multiplying by that number's reciprocal. So I can multiply by the reciprocal, which is just the flipped version of this fraction, on both sides to cancel out this negative 3/4. So I'm going to rewrite my equation. Negative 3/4 n equals negative 2. And then I'm going to multiply negative 3 over 4's reciprocal, which is negative 4 over 3. And I'm going to show my multiplication in a specific way because this is the easiest and cleanest way to do it. So I'm going to put a set of parentheses around negative 3 over 4 because I can put a set of parentheses around anything. And we know that a number next to parentheses means multiplication. So I'm just going to write negative 4 over 3 right here. So this just means I'm multiplying the left side by negative 4 over 3. But remember, if I multiply the left side by negative 4 over 3, I need to multiply the right side by negative 4 over 3. So I'm putting parentheses around the negative 2, and I don't want to start with a negative number next to this for multiplication because it might look like subtraction. So I'm going to put negative 4 over 3 inside the parentheses. Now, if you look at these fractions, these are going to cancel. This is why we're multiplying by this reciprocal, because negative 4 over 3 times negative 3 over 4, you could do it out. If you cross cancel, both numbers will cancel, the negatives will cancel. We're just left with 1 here, 1n, but anytime we have 1n means 1 times n, which is just going to be n. So everything here cancels out, and I'm just left with n, which is great. Now over here, I'm multiplying negative 2 times negative 4 over 3. First thing I would do is negative times a negative, which is a positive. And then what you can do, you can just do the tops times the bottoms. We don't have a bottom here. If you wanted to, you could write in over 1. You don't have to. But this is just going to be 2 times 4 on the top, which is 8, over 1 times 3, which is 3. Now, you can keep this as the improper fraction. This is completely simplified, so this is a possible answer. You could convert this to a mixed number, which would give us 2 2/3. Or if you really wanted to, you could write this in decimal form, which is 2.6 repeating. But you only need one of these answers. But either way, we are done. You can check your answer if you want to make sure you get the correct answer. For the next example, we have the equation pi x equals 3 pi. Now, you might be a little confused because you see some Greek character in this equation. But remember, pi is just a number that represents a circle's circumference divided by its diameter. It's what we call a constant in math. So this is just a number. So this is really just x times number equals 3 times that same number. Well, we treat this equation the exact same. So we have pi x equals 3 pi. So we want to isolate our variable x, so we want to see what's happening to x. Well, anything next to anything else in math means multiplication. So we know that pi is being multiplied by x. In order to cancel out multiplication, we can use division. So I'm going to divide by pi on both sides. So there's a very specific way I want you guys to be writing division when you're solving an equation. And that is using the fraction bar. Remember, a fraction means division. So we're going to do divided by pi here. But remember, if I divide pi on the left side, I also have to do it on the right side. So I'm going to divide by pi here. And since I did the exact same operation on both sides of my equation, I'm going to get an equivalent equation where my value of my variable is going to be the exact same. So let's look what's happening here. I have a pi on the top and a pi on the bottom. Well, anytime I have a number on the top and the bottom of a fraction, they cancel. So I'm going to cancel that out. And if you look over here, the same thing's happening. I have pi over pi, and that's going to cancel as well. So now all I'm left with is x equals 3. And that is my final answer. If you plug this in, for x, you'd get pi times 3, which is the same exact thing as 3 times pi. Order does not matter in multiplication. So now we're done with this example. All right, now we have a multiple choice question. What value of k makes the equation k plus 4 divided by 0.2 equals 5 true? Well, this equation is slightly different because it is not simplified. We need to simplify everything before we do any canceling operations. So I'm going to rewrite my equation. All right, so the first thing I see is that I have 4 divided by 0.2. Now, I don't like this division symbol. You'll see the fraction bar more and more as you go through your math career. So I'm just going to rewrite this as 4 divided by 0.2 as a fraction. So this is the same exact thing as k plus 4 over 0.2. Now, you don't have to do it this way, but this is the way that I would strongly recommend. Now, when we're trying to simplify a fraction, we don't like having decimals in it. So what we want to do is we want to get rid of this decimal. And one way we can do this is just move this decimal over to the right one space. But that's the equivalent of multiplying by 10. So if I move the decimal over one space on the bottom, aka multiply by 10 on the bottom, I have to do that exact same thing on the top. So I'm going to find my decimal, which would be right here. And then I need to move that over. But if there's nothing to put here, I need the placeholder. So what placeholder am I going to use? It's going to be 0. So now this becomes k plus 40 over 2, because 0, 2 is the same thing as 2. And notice how I'm showing every single step of my work here. This is exactly what I want you guys to be doing. Okay, so anyway, I have k plus 40 over 2. This is still not simplified. So I need to simplify it. Well, I know what 40 divided by 2 is. That's just cutting 40 in half. That's 20. So k plus 20 equals 5. And now I have an equation just like the ones we've been doing. So this is the same thing as k plus 20 equals 5. So in order to cancel out the addition, which is happening to k, remember we're trying to get k alone, I want to subtract 20 or add negative 20. Remember, that's the exact same thing. So I'm going to subtract 20. But if I subtract 20 from the left side, in order to keep my equation true, I have to do that exact same operation on the right side. So I need to subtract 20 on the right side. So now I get k equals, well, 5 minus 20. I know my answer is going to be negative 15 here. So this is my answer. So let's go back up to the multiple choice and find negative 15. And I see that that is choice A. So I'm going to put a box around choice A. Now we're done with this one. All right, so the temperature in a crater on Mars is 0 degrees Celsius at 1 p.m. The temperature decreases 8 degrees Celsius every hour. When will the temperature be negative 50 degrees Celsius? So if the temperature is decreasing by 8 every hour, that means after the first hour, it'll be negative 8 degrees. The second hour, it'll be negative 16 degrees, and so on. So what's happening is we're multiplying the number of hours by decreasing by 8. But remember, decreasing right here in math, that means negative 8. So we're multiplying the number of hours by negative 8. And we want an equation, and we want to figure out what time it will be, how many hours will pass at negative 50 degrees. So we want this negative 8 hours to equal negative 50 degrees. So now I have my equation. Negative 8 times the amount of hours that have passed equals the final temperature that I want, negative 50 degrees. So I have a negative number being multiplied by h. So in order to cancel out multiplication, I'm going to divide by that number. And we divide by everything, not just positive 8, by the negative 8 as well. So I'm going to divide by negative 8. But remember, if I divide by negative 8 on one side, I have to do that exact same thing on the other side in order to keep my equation true. So now, I look over here, the negative 8 on the top and bottom, these are going to cancel out. So I just get h. And then here I have negative divided by negative, which is a positive. So I'm going to get a positive number, which makes sense. And then I have 50 divided by 8. So one thing we can do is just keep simplifying this fraction. Well, I know that both of these numbers are even, so I'm going to divide by 2 on the top and bottom. So that's going to give me 25 over 4. And I actually can't simplify this anymore. So I'm going to because this question, the context of this question, I'm going to turn this 25 over 4 into a mixed number. So 4 goes into 25 6 times. And then I'm left with a remainder of 1, because 4 times 6 is 24, plus 1 is 25, and 1/4. So remember, h right here, h is the variable that we assigned the number of hours. So after 6 and 1/4 hours, that's when it's going to be negative 50 degrees Celsius. But we want a specific time for that. So if we start at 1 p.m. and we go 6 hours after that, that's going to be 7 p.m., but we need 1/4 of an hour. If you remember, 1/4 of an hour is 15 minutes. So if I have 1 hour plus 6 hours and 15 minutes, that time's going to get me 7:15 p.m. And every time we have a word problem, we want a word answer. So when will the temperature be negative 50 degrees Celsius? We can write the temperature will be negative 50 degrees Celsius at 7:15 p.m. I'm going to put a box around my answer. And now we are done.